Well, hello and welcome to Math Blossoms, where growing in mathematics is natural. Today's math topic is how to solve equations with cubed or with squared variables. So let's get started. I'm going to provide quite a few examples of this as we go so that everybody can kind of see exactly how to do it, and also what type of solutions we're going to get when we do the squared variables and also when we do the cubed variables. So we're going to start with squares, and it says, there we go. How do I solve simple equations that have squared or cubed variables? Well, the answer is to use inverse operations to isolate the variable. That's pretty much what we do when we solve any equation. So a lot of what we do when we solved equations like this is very similar to what you've done with one-step equations, two-step equations, where wherever the operation is that's happening to the variable, you're just going to do the opposite or the inverse of that to cancel it out. At the very final step, though, you're either going to take a square root or a cube root in order to cancel out the squared variable or the cubed variable, because taking a square root is the opposite of a squared number or quantity, and taking the cube root is the opposite of cubing a square variable or a quantity. So here's some examples. We're going to start with some square roots first. Actually, let me just start here. I don't want to confuse anybody. What I tell students when they're first learning this is if you get confused about the variable and the exponent being on that variable, just kind of erase it. Just pretend it's not there. Like I'm just whiting it out here just as, pretend it's not there. And then take another look at the equation. Now it's a little easier to see what to do. As you can see, we're subtracting 5 from x. So the only operation happening to the x is a minus or a subtraction. So we need to do the opposite or inverse of that, which means we need to add 5 to both sides instead of subtracting 5. So let's go ahead and do that. We're going to add 5, and of course a minus 5 and a plus 5, those are opposite numbers. So when we add those together, they just disappear. They're gone. They become a 0. And when we do adding the 5 on the other side of the equal sign, because remember when we solve equations, whatever action we take to one side of the equation, we need to do it to the other side to keep the equation balanced or equal. 11 plus 5 is 16. So we're going to rewrite that equation, leaving out the stuff that we just canceled out. And now that we're down to this point, it looks like we're finished, but we're not, because remember we have this little squared up here. So I'm going to go ahead and write it here. And the way we get rid of the squared variable is to do the inverse or the opposite, which is to take the square root of both sides. So I'm going to take the square root of x squared here. And then I'm also going to take the square root of 16. Okay, so when I take the square root of x squared, remember the square root is a question. It's asking you what times itself will get you the quantity that's underneath the square root symbol or the radical symbol. What times itself is x squared? Well, that's an x. I'm just going to write it over here because we're running out of space here. Okay, so what times itself? Well, x times x is x squared, right? So the square root of x squared is x, and then what times itself is equal to 16, and that would be 4. But here's where it gets weird on us. There's actually another answer, and the answer is negative 4. So when you're solving equations and they're asking you for possible solutions, 4 times 4 is 16, so we know that works, but negative 4 times negative 4 is also positive 16. So in this situation, when you have a squared variable, you're going to have 2 possible solutions. All right, let's try another one. We'll change colors here to, here we'll use orange this time. Okay, again, if you want to, cancel out this 2 to make it a little easier, here, we'll do that one more time and then I'll stop doing it, just to show you that sometimes it's easier to see what to do if the little exponent's not there. So if you want to just pretend it's not there for a moment and then look at the equation, well, we're adding a 2. So what's the inverse or opposite of adding a 2? And that would be subtracting 2. So we're going to subtract 2 to get rid of the 2 and isolate our x here. And then we're going to subtract it on the other side again and get a 9. Now we can erase our little exponent here and put it back where it goes. And we're going to end up with x squared on the left side of the equation. And on the right side, we will have a 9. Okay. Now the last step again is we need to get rid of that exponent of 2. And to do that, we take the square root of both sides. So I'm going to take the square root of x squared here and also the square root of 9. And remember, the square root is a symbol that asks what times itself is equal to the quantity that's under the radical symbol or the square root symbol. And in this case, it would be x, because x times x is x squared. And over here, it would be 3, because 3 times 3 is 9. But also, negative 3 times negative 3 is 9 as well. Now, sometimes you might see these answers when you have the 2 possible solutions. Sometimes you might see it written like this: positive and negative 3. Some folks like to, write it this way. They both mean the same thing. If you write 3 and negative 3, or plus and minus 3 like that, it means the same thing. All right, let's do another one. This time there's multiply going on in our equation. 2 times x squared. So again, pretend the x squared is not squared and it's just 2x, right? 2x equals 50. Well, what are we going to do to change to get rid of that 2 that's being multiplied times x? We're going to do the opposite, which is divide. So we're going to divide by the same number 2 on both sides of the equation. And 2 divided by 2 is not 0. Like it, we cancel these out by making them 0. 2 divided by 2 is 1. And we do want 1x. Remember, if there's no number in front of the x, there's only one of them. They just don't write the 1 that's there, but it really is there. So don't forget that we have a lot of invisible ones in our math sometimes. Now, we end up with x squared equals, and then 50 divided by 2 is 25. And the same we have to do over here as we did in the first 2, and that's take the square root of both sides in order to get rid of the exponent on the variable. And when I take the square root over here, I'm going to get an x. And when I take the square root over here, I'm going to get a 5. And a negative 5. Again, when you have these squared variables, you're going to end up with 2 possible solutions. And you need to know that for this concept, for this topic, it will be on the quiz and on like your state tests at this math level. Okay, the last one is a one-step equation. All of these are pretty much one-step equations that just have that, it's technically a one-step equation with an exponent, and you have to perform 2 steps because you have to get rid of the exponent. But there's really only one operation we're undoing. And in this case, we are undoing division because this is x squared divided by 2. So we're going to do the opposite, which is to multiply times 2. So if I multiply 2 is the same as 2 over 1. Like if we were to put that in a fraction form, if I multiply a 2 that's in the numerator times a 2 that's in the denominator, they're going to cancel out, and you're just going to be left with the x squared. Okay, so remember, doing the inverse operation will cancel out the operation that's already in your equation. And then when I multiply the 2 over here on the other side, I get a 16. And of course, the final step is the same as the other 3 equations we did, where we take the square root of both sides to get rid of that 2 on that 2 exponent that's on our variable. And when we do that, we end up with x, because x times x is x squared, and also 4, because 4 times 4 is 16, and also negative 4, because negative 4 times negative 4 is also positive 16. So now we've done quite a few with square roots. So the takeaway from this is that when you have square roots or when you take the square root because your variable squared, you're always going to have 2 possible solutions, positive and negative. But I do want to show you something that might pop up when you're solving equations like this. What about cubed variables? We're going to talk about that. Cubed variables will result in only 1 solution. So we're going to do a few cubed equations, and then I'll show you something else about squared. I thought I had a slide on that, but maybe I don't. Okay, so here's our first cube equation. And basically, we're going to solve them the same way we did the squared equations. Here, I'll start with blue again. I think I started with blue last time. We're going to first subtract the 1 from both sides because we are adding a 1 to the variable here, and we do need to inverse that out. So we end up on this one with x cubed equaling 27. Now, once we get to the point where all we have is the x with the exponent, to get rid of a cube, we're going to do the inverse of cubing a number, and that is to take the cube root. Taking a cube root is asking the question, what number times itself is equal to the quantity under the cube root symbol. And the cube root symbol is just like the square root symbol, except it has this little 3 here to the left of the radical symbol. That way you know it's a cube root and not a square root. So what number times itself is x to the 3rd power, and that's x, right? Cube rooting a number is going to reverse out the cubed x, right? Because x times x times x is x cubed. And then what number times itself is 27? Well, that would be 3. 3 times 3 times 3 is 27. Of course, you can put this in your Desmos calculator. I will show you this in just a moment. There is one other thing I need to show you as well about the squared variables, but right now we're just doing cube variables. Now, does negative 3 work? Because we know that 2 solutions work with the squared variables. Do 2 solutions work with cubed variables? Let's try it. So negative 3 times negative 3 times negative 3. Now, if we do the negatives, we're going to end up with a negative 27, not a positive 27. So the negative answer does not work. Only the positive answer works on this cubed variable. That's what they mean about cube variables will result in 1 solution, either positive or negative. In this case, it's a positive, but you can have one that will result in a negative. Let's erase this so people don't get confused. Okay, now we'll do, what was next? I think I did red next, maybe. X to the 3rd power minus 5 equals 59. Okay, so we got to get rid of this minus 5 first by doing inverse operations. And the inverse of subtraction is add. So we end up with that. And 59 plus 5 is 64. Okay, rewriting the equation, leaving out the stuff we canceled out. We have x to the 3rd power equals 64. And so the final step is the same as the first one we did, and that is to take the cube root of both sides. So we're going to do that. Cube root of x to the 3rd power. And then we'll take the cube root of the 64 as well. And in this case, we end up with x equaling 4, because 4 times 4 times 4 is 64, and x times x times x is x to the 3rd power. 1 solution. The third one, we have x to the 3rd power plus 1 equals negative 26. Let me change colors again. And this time we're subtracting 1 from both sides to start off this solving of the equation. And we end up with x cubed equals negative 27. Negative 26 minus 1 is negative 27. And of course, we do the same thing that we did in number 1. Ooh, hang on a second. Well, that's okay. We take the cube root of both sides. And over here. And the cube root of x to the third power is x. X times x times x equals x to the third power. And what number times itself is negative 27. That would be negative 3. So here we have one solution that's negative because the number under the radical is negative. So as you can see, we got the same answer on on the first one we did over here in blue. But notice this one's positive, so the answer is positive. But when this one's negative under the cube root symbol, then you're going to have a negative answer there. And then the final one, we're doing x cubed minus 5 equals negative 69. Let's change to green and do that one real quick. We're first going to add 5 to both sides because inverse operations. All right, and this is going to cancel out and give us just the x to the third power on the left side of the equals. And then over here, we end up with negative 64 because negative 69 plus 5 is negative 64. And then we take our cube root at the final step to get rid of the cube exponent that's on our x. And we take the cube root of the negative 64 as well on the other side of the equation. And we end up this time with x equaling negative 4. And this is very similar to the one we did in red over here. But in this case, we have a positive quantity under the cube root. So we had a positive answer. And this time we had a negative, which means we had a negative answer. All right, now this is something that I wanted y'all to look out for. Now we're switching back to squared numbers, not cubed numbers or quantities. It says, did you know that it is impossible to find the square root of a negative number? So let me explain how you might see this, and I don't want you to get the two confused. The first is this, the square root of negative 16. Now, let me change it. We'll go back to blue. Okay. If you really think about it, you know, the question you're asking is what number times itself is equal to negative 16? Well, 4 times 4, that number times itself, gives us a positive 16. So that does not work. And then negative 4 times negative 4 gives us a positive 16. And that also does not work. Okay, so there really is no solution to this because we would need two different numbers. We would need a negative and a positive in order to get that negative quantity here. Okay, so if you ever see a negative underneath the radical symbol and you try to put that in your Desmos calculator, you're going to get the word undefined. I'm going to show you that in just a moment. Undefined. Which in a nutshell just means there's no solution. And you can write undefined or no solution. I have seen it written both ways. So look out for negatives like that. Now, if it was a cubed root, we could answer that, but it's not. It's a square root. So we can't take the square root of a negative number. But you might see something like this. And this is very different than this one here on the left. This one, the negative is outside of the radical. So when the negative's outside, it's like a negative 1 times whatever the square root of 16 is. And we know the square root of 16 is a 4. So what you really have is negative 1 times 4. Another invisible negative 1 there. And we know it because it's outside, like this negative is inside over here. This one's outside, so we know it becomes a negative 1 when it's sitting out there. So the answer is negative 4 on this one, because a negative 1 times a positive 4, which is the answer to that one. is -4. Okay. And in this case, we're not using the negative version of the answer. We're just talking about the positive because I wanted to show y'all the difference between having that negative under the square root and having that negative outside of the square root. So be on the lookout for that. Okay, before we do a review, let me go to Desmos so I can kind of show you guys a little bit of that. There we go. Okay, so let's try. So this is the square root symbol. So if you're using your Desmos, you're going to want to click that. My cat's meowing. Sorry. Tyson, I'll be with you in a minute, hon. Okay, so if I'm finding the square root of 27, sorry, not 27, 25, square root of 25, square root of 27 is a non-perfect square. Okay, this is a perfect square. It's giving you the 5. But remember, when we're solving equations and they're asking for all possible solutions, you need to remember that -5 also works as an answer. Your calculator will never give you both answers. It will always give you just the positive answer. So you just have to remember that -5 also works here, okay? Because -5 times -5 is also positive 25, okay? Now, if we're finding a negative outside, like our example said, outside of the square root, and we're putting that 25 here, it's going to give you that -5 that I was just talking about, because this is like -1 times the positive square root of 25, and -1 times the positive square root of 25 is -5. If the negative is inside the square root radical, you're going to have undefined, no solution, because there is no number you can multiply times itself to get a negative. Okay, you can do a number times itself to get a negative, but not just a squared number. Okay. So that being said, let me show you how to use the cube root. Just to the right of the square root symbol is this little symbol here with the little n, and that stands for any number. So when you click on it, your cursor is going to be right there, and to find a cube root, you're going to want to put a 3 here, and then whatever number you want to find the cube root of. If we wanted to find the cube root of 27, it's going to give you 3. If it's -27, it's going to give you the -3 answer. Okay, so let's recap. Let's go back to the PowerPoint here. I'll be right with you, Tyson. There's nobody home, so he's lonely. Okay, great job, y'all. Remember that when solving equations that have squared variables, there will be 2 possible solutions, both positive and negative. Remember that the calculator will only show the positive answer when taking the square root of a number, even though the negative answer is still correct. It's both. It's 2 solutions. Remember that you cannot take the square root of a negative number. You can take the cube root, but you cannot take the square root. And remember that when you are solving equations that have cubed variables, there will only be one solution, and that solution may be positive or may be negative, depending on what's underneath that cube root symbol. If the cube root symbol has a positive number that you're trying to take the cube root of, then you'll have that positive answer. If you're trying to take the cube root of a negative number, you'll have that negative answer. So that negative answer. Woo! I'm going too fast for my mouth. So that concludes our lesson for today. So study hard, and you'll do well on solving these equations with squared and cubed variables. And now it's time for me to say it was lovely teaching you math today. Bye-bye.